The historic heat wave roasting St. Louis for days in August turns out to be some of the hottest conditions St. Louis has ever experienced.
So, for instance, in St. Louis today, on this particular day, the temperature I'm looking up at the thermometer reads 96. The heat index, however, is 116. It's about, feels like it's 20 degrees warmer because when I go outside, the air is so humid and muggy, my body can't cool off by sweating.
The heat and high humidity make being outside unbearable, even in the shade.
If the air is already saturated in water vapor, then the sweat will just stay on you. The water doesn't evaporate. You don't cool down.
For sports, some outdoor games and practices are delayed or canceled. Fewer people are seen taking walks in the heat of the day unless it's with a purpose, getting to that next air-conditioned building. And at night, when the temperature drops, the evidence of high humidity is clearly seen.
When you wake up in the morning, you see that there is all this water on your windows or your glass doors. It's because during the day, when it's up close to 100, the water evaporates off the ground and the air becomes saturated at a temperature of 100 degrees. As it cools overnight, even down into the mid 80s, it passes below the dew point for all the water vapor in the air. The air can't hold as much of that water vapor in it. It has to go somewhere, so it condenses out onto objects like the windows.
He says the heat in St. Louis is from the heat dome in the southern U.S., making an unwelcomed visit to the Midwest.
The heat dome in the southern U.S. has stayed locked in. And in this case, even though the heat dome has shifted, some days we don't feel it in St. Louis at all. Some days it does extend right up, north past us.
As professor of Earth, Environmental, and Planetary Sciences at Washington University in St. Louis, Michael Wysession is closely observing all factors contributing to the historically hot summer.
We're most familiar with the heat dome that has been sitting over sort of the South Central U.S. There have been 3 other heat domes. There's one in the Atlantic and one in North Africa and one in Asia. A heat dome is a case where the air currents keep a particular mass of hot air pushed down in a particular region of the earth. You have a particular type of air that flows when there's a very high pressure region. And that high pressure, that added mass, sort of holds down the warm air near the surface and doesn't let it sort of blow away as it normally does.
July 2023 is confirmed to be the Earth's warmest month on record by a large margin. And Wysession says 2023 may become the Earth's warmest year on record.
Usually these heat domes last for a matter of days. This year it's been exceptional. We've had some of these heat domes last for weeks, keeping one part of the earth hot for extended periods of time.
He emphasizes extreme heat is deadly.
More people die in the U.S. from heat waves than any other weather-related impact. Many people are not prepared for extended periods of high temperature. Many people don't have air conditioners. They don't have adequate access to water. It has been predicted, for example, that if Phoenix were to lose its electrical power during one of these heat domes, about 85% of the population would end up in the emergency room of a hospital. And obviously, there aren't enough hospital emergency rooms in Phoenix to handle 85% of the population. But it shows the precarious nature, because if there were to be a massive power outage for one reason or another, this would be deadly on a massive scale.
Wysession explains the dangerous heat is from global warming.
Most of the warming that we're experiencing now, compared to how things were back when we were children, the world was cooler at that point, most of that is due to the greenhouse gases in the atmosphere, and those have come from burning fossil fuels, coal, oil, and natural gas.
And he says there are natural factors contributing to global warming, like El Nino.
heat comes out of the ocean into the atmosphere, and the whole world on average is a little bit warmer. This is the most important factor other than the human factor.
The 11-year solar cycle.
And we're going to hit our peak in about 2025, where it gives a little bit more heat.
And the largest volcanic eruption of the 21st century.
That happened in Tonga back last year was a shallow underwater eruption. And the added water vapor from this eruption, very powerful greenhouse gas, also is contributing, and probably will for several years, to the global increase in temperature just a little bit. So you take the warming from us, the greenhouse gases, you add an El Nino, you add a solar maximum, you add this Tonga underwater volcano, and what you get is record-breaking temperatures for this year.
He says it's not over. More hot summers are expected, which means St. Louis will see more of this.
Climate forecasting is very analogous to weather forecasting. You look at how things are today, the other factors involved, the greenhouse gases, volcanoes, El Nino, sun oscillations, and say, all right, there's a 20% chance of having a heat dome that will last for 3 weeks next summer. The best we can do is provide these probabilistic forecasts. And the way things are looking right now, the odds are much higher that there will be another summer of devastating heat domes next year. Do we know that this is going to happen? Absolutely not. Just like the weather. Do we really know that it's going to rain Saturday? No, but the weather forecasts are doing much better now than they were 40 years ago. Computers have gotten better, data is better, and the same thing happens with these climate models. So we can look at the factors that made the heat domes this year, and we can look ahead to next year when all of these same factors are still going to be in play and say, we'll probably break a bunch of heat records again next summer as well.